Okay, so I've just built a little, I guess you could say it's a computer lab in the test world. So this is underneath where the platform is that I just showed you. Um, this is a Red Power 2 computer. So what I've been trying to do is to work out some code that I can use to run that. What it can do, you can have it input like read and write signals onto different coloured insulated wire. So yeah, you can interpret, say if I turn this lever on, I can check to see if that colour wire is active, that kind of thing. So yeah, so what I've done is use that ability and set up some lamps here that are like pretend versions of what's on the platform. So I've got this one here, which is a mining pipe retrieval signal. So this is going to say yes, all the mining pipe is back in the chest from after a drill, or no, it's still out there, whether it's on or off. And this one here is the frame motor activating, and this one here is the drill release button, and this lamp here is the manual cutoff. So say I want to have a lever. Yeah, okay, so here's one here. So this wire here is on the same frequency as this. So if this manual cutoff is on, then the platform will stop moving after the current drill. So it'll get to a certain point and then stop. That's the plan anyway. I want to do something like that. So it won't keep looping and start a new drill. Alright, so yeah, I set up all these different colors in case I needed different signals for different things, and then I could start coding. Now, I've done a little bit of coding, but I'll show you what I've done anyway. I'll code it again just so you can see what's going on. Okay, so I'm just gonna change it back to dawn. There we go. And if we have a look at the computer, so you can probably see some of them there, some of the Forth words that I've written. There is actually a lot of Forth documentation online. I didn't know anything about it until I started this, so it's not too hard to learn. But if we'll define the words again, just so you can see how it works. So colon and a name, we'll set that up. So if we go colon move platform. Okay, and then we want move platform to do, now 2 is the orange wire. These are the they're like binary codes, I guess. So you've got 1 for the white wire is the first one, 2 is orange, 4 is the third one, I forget which color that is, I think it's purple, 8 is the light blue wire, and they keep doubling as you go up, so you'll get 16, 32, 64 and so on, and there's 16 different colors, so there's a lot of different wires you can use for data transfer. So 2 is the orange wire. This is to move the platform, so we're gonna use the orange wire as the frame motor signal, and IOX is this next bit. IOX is the IO expander. It's that little modem looking thing down here, that's attached to the computer at the back with a ribbon cable, and that basically adapts the ribbon cable into the bundled cable with all the different colors. So we're sending a signal to the IO expander, and we're setting the second wire to on, and that's what that does. So we'll do that, and then 20 ticks, so this is a delay. 20 ticks is about 1 second, so we want a 1 second delay, and then we want to turn it back off again. It's that one, so reset, IOX reset. Right, so basically it sends a pulse to the frame motors and then turns the pulse back off again, and then we want to wait about 20 seconds. No, we don't. We want to wait about 3 seconds, so 60 ticks, because this move platform thing, this is only doing one single move, but if we're doing multiples, then we want it to give it time for the whole thing to move, and then we can do it again. So if we go, so that's the first one, that's move platform, and then activate, activate miner, whoops, like so, and then this one is going to have a loop at the beginning, because it's going to wait until the mining pipe's retrieved, and that's what that thing is. So the first wire, wire 1, is the mining pipe retrieval signal, so that's that. IO expander @ is reading a value from the IO expander on, and then you specify which one, and 0 equals. So it's going to wait for that wire to be off. So it'll be sitting there on, and when it's off, then it will activate whatever comes next. So okay, until, so it sits there and waits until that happens, pretty much. Okay. Then carriage return. Then we want to put a little, because it doesn't carriage return on its own when you do a command, it just sits there. So, and then we want to tell the user that all mining pipe retracted, initiating frame movement. Right. Then we'll carriage return again. Then we will, let's see, what will we do next? Then we will 18 times move platform. So it's going to run move platform 18 times to activate the frames 18 times to move the platform 18 blocks, because the miner has a 9 block radius or an 18 block wide section that it does. So we want to make sure we move it 18 times. Alright. Then we will print out again. So this dot and then quotations. So you can dot to print whatever to the output, to the screen, and quotations is just so you can write in any text, but you can print any string. So you could set a variable up and print that if you want, if you wanted to. So this one will be frame move completed, releasing drill. Okay, and then we want to release the drill. So the drill is on the next wire, which is wire 4, IOX set, and then we want it's only got to be a pulse when it's like a button. At the moment it is a button, so we want it to work like a button, so we're just going to pulse it. So we turn it on, and then 20 ticks, so 1 second, and then we turn it off, IOX reset. And then what I've done after that is a 20 tick delay. It doesn't really need, it can be pretty much anything, any number, as long as it's long enough for the drill to get into the miner through the tube. And I figured 20 seconds would be about enough for that, because the bat box has to start getting used. If the delay isn't long enough, then there'll still be a full bat box up there, and the system, it probably won't work very well. It's going to probably try and reset again. It'll check for all the mining pipe and all that sort of stuff again. So we want to make sure that it's actually drilling before it does anything else there. And that's the end of active miner, so we'll close that one off. The semicolon there tells it that it's the end of the compile. So now that running active miner should do a complete drilling and then stop. It'll move the frame 18 times and then activate the drill release, and that's it. So you'll get one mining thing out of that, because once the drill's finished, the platform automatically retracts the drill, so that's native to the actual build. We don't have to program that. But yeah, it's not going to go on and do the next one. You need to run active miner again. So you can have another one. What I was trying to do is another program that looped and kept running active miner. But the problem I was having is to have it check the manual cutoff, it only checks very briefly in between those loops. So yeah, it's not going to there's not going to be a very instant result to a manual cutoff switch. So I'm thinking probably a better idea is just to leave active miner as the main program, and then when it's finished, maybe we'll have it send another signal. We'll IOX set, I don't know, 8 or 16 or something, and then have a lamp come on in base. Just let us know that the miner's finished, and we can I don't know, pull a lever or press a button or something and have it start up again. So yeah, that's probably a better alternative, having it like that. So that's how that works. Now, if we want to see it on the lamps to make sure that it's doing what we want, we can run activate miner, like so. So there's your thing there. Now the frame movement is this. So frame goes on, frame goes off, frame goes on, frame goes off. Now it's going to do that 18 times, just like that. Now instead of this lamp, or maybe as well as the lamp, really, I don't have to replace the lamp. Instead of the lamp, I can have another orange cable like that somewhere. I can hang that off anywhere really, and put a wireless transmitter on the end, and on the other end of that have a wireless receiver up here on the frame motors. Now yes, it goes in multiple directions, but we're probably not going to need it to go in multiple directions all the time. Maybe if we wanted to manually move it to a new area or something like that, we'd want that, but for the sake of just drilling, it can just have one. And if we wanted to, we could even change the frequency on the wireless transmitter. Okay, see this? That was the drill release. So it did this 18 times and then it drill release. So that bit actually works. Now, if we do that again, do you remember the mining pipe release thing? So that simulates the mining pipe not being ready. It hasn't retrieved the mining pipe yet. So if we run activate miner again, it's going to just sit there, and it's not going to do the frame motors because the mining pipe hasn't come back yet until we do that. Bingo, frame motors are moving. So as soon as it sees that all the mining pipes come back, it's off, and away it goes. And we'll get to the new location, and then the drill release activates, and then it's going to wait its 20 seconds, and the drill's going to start drilling down, and yeah. So it all happens on its own at that point until the next time this mining pipe comes back. Now we can actually get that signal, like at the moment I'm just using a lever to simulate that, but we can actually get that signal from a sensor on the chest itself to detect how much is in it, or we can get maybe a red power item detector on the tube to count the items, something like that. So yeah, there'll be a few different ways we could do that. So yeah. There we go, drill release, done. And then you'll wait us 20 seconds and the program will finish. we should do. There we go. Excellent. Just like that. So it's not that hard to do. There's plenty of documentation on Forth online, and yeah, so a little bit of reading was all I needed to do for that. And yeah, I'm sure these aren't too hard to craft. I think you need a diamond for the computer itself, this bit down here. The monitor, I think the hardest thing to get was like lime dye, but I've got plenty of cactus, so that shouldn't be too hard. The disk drive. So you don't actually need a disk drive for this, but if you want to save the program onto a disk, like one of these, then yeah, you need a disk drive for that. So I don't think it's that one. That's the boot disk. There's a blank disk. Yeah, one of these. Okay, so if I get rid of, so I get a blank disk. So what you can do is you can put your blank disk in, and then you can go. I think you can even name it. So disk name. Minor. No, hang on. Words will tell you what all the words are that have been done. Disk name. Oh, okay, you need capitals. Disk name. Minor. There we go. And then you can go save, and that'll save the programs like that. So nice and easy. Yeah. Alright. Well, so that gives me a bit of a basis of what I'm doing on the Survival World platform. That's how I'm going to control it using these. And yeah, and I may even keep the lamps. Like the lamps are a good emulation of what you want to do, but putting the lamps in a wall and putting signs next to them, so you can see what the miner's doing remotely. You can just stand in your lab basically and look at the wall and go, oh yeah, okay, it's moving the frame again. So yeah, that wasn't actually intentional. I wasn't trying to do that. I was just emulating it, but it seems like it's going to be a good idea doing it like that. So yeah, alright. Well, I'm going to go back to the survival world and keep building, and I'll see you in a bit.